This week's homework video is all about percentage and ratio. These are two areas that are linked to the fractions homework we've done over the last 2 weeks. And this is the aiming higher version of the video. Now, percentage is a system that was invented to try and make comparisons between different sets of data. If I'm trying to work out which basketball player is the best at scoring free throws, shots from the foul line, I can't just look at how many shots they scored. I also need to consider how many shots they've taken to work out who's the most likely one to score. Clearly, Henson's going to score more from his 600 shots than Dominguez is from his 25. But if I can work out how many shots each player will make if they were given 100 efforts, I've got a kind of standard way of comparing their performance. If Dominguez is making 17 from 25, I can assume that from 100 shots, 4 times as many, he'll make 68 of them, 68% out of 100. If Henson's making 312 out of 600, to work out how many he'd make out of 100 shots, I need to divide by 6, 52%. And in the same way, 780 from 1,000 would mean I'm making 78 for every 100. And now I've got a standard measure. I can see, well, Iverson makes the highest proportion, and then it's Dominguez, and then it would be Henson. Percentages are often used to analyse sports performance. An interesting case was DeAndre Jordan. Statistics show that as a percentage, he makes a lot of shots near to the ring. However, when he's shooting free throws, his percentages aren't as good. Now, on the previous page, we had a look at ways to find percentage to make it out of 100, but of course in the real world, the denominator isn't always easy to cancel down to make it out of 100. In this case, DeAndre Jordan made 119 free throws out of 306 shots. Now, how do we find that as a percentage? If we do 119 divided by 306, to the nearest 3 decimal places, that would be 0.389. Then, to convert a decimal into a percentage, I just need to times by 100. So his accuracy from the free throw line would be 38.9%. We can tell that's about right because 119 is just less than half of 306. Now, the very best basketball players from the free throw line normally make between 85 to 90% of the shots. So you can see, as a percentage, this one's very low. Now, to find percentages, you'll need to be able to see the link between fractions and percent. A half is 50%, because 2 lots of 50 is 100. A quarter, 25%. 4 25s, 100. A fifth, 5 20s are 100, so a fifth is 20%. A tenth, a crucial one when we're finding percentages, of course, 10% is 100%. Now, you can use this knowledge to work out most simple percentages. Have a go at working out these 3 percentages of amounts. Pause the video. Now, first of all these calculations require more than one step because the 3 numbers that we've got, 15, 90 and 35, don't go into 100. For the first example, I'm likely to work out that 10% of 80 is 8, 5% must be half of it, 4, and so if I add those 2 together, of course, I'll have 15%, 12. For the second example, I'm likely again to work out 10% must be 70. Now, I could either do 9 lots of 10% to get 90%, or I could take the whole, 100%, 700, and take off 10% to leave me with 90%. Either way, getting to 630. Now, I think the easiest route to finding 35% is to find 25% by quartering, to find 10% by dividing by 10 for 20 and 8, and adding them together, 28. Now, have a go at these 3 percentage questions. The key for the first one is writing it as a fraction. I've got 10 shaded blocks out of 25. Now, I'll know to make that out of 100, I'll need to multiply by 4. So, 100 as the denominator and 40 as the numerator, giving me 40%. I can check that by looking and realising, yeah, it is slightly less than half that are shaded. Now, if 40% of a number is 72, another 40% of the number must be another 72, so that's 80% of the number. I just need to work out what 20% of the number is. 20% of the number must be 36. half of 40%. So the whole number, when I add all that up, must be 180. I could of course check that by working out 180, 10% of it's 18, 18 times 4 is 72, so it is definitely right. And for the last one, if I've got 17 out of 20, to work out what that would be out of 100, of course, I'll need to multiply it by 5. So that'll mean it'll be 85 out of 100, and of course that means it's 85%. Now, ratios very closely linked to fractions. If we consider this made-up statistic, 2/5 of Real Madrid's goals are scored by Cristiano Ronaldo, then I'm saying 2 out of every 5 goals scored. So, for every 2 goals that Cristiano Ronaldo scores, 3 are scored by his teammates. Now, in this fraction, the emphasis is more on comparing Cristiano Ronaldo's goals to the total number of goals scored by the team, the total, which is 5. As a comparison, have a think about mixing paint. Every 3 units of yellow paint is needed for every 2 units of blue if I'm going to make the same colour of green. Here, the ratio, again, is 3 to 2. The total number of pots of paint for each mix, if you like, would be 5. But in this case, the thing that's more significant is the ratio of yellow to blue. The ratios, you can see, compares the parts, where the fraction considers the whole. Have a go at these 2 ratio questions. First of all, I'll lay all the information out. 2 for the baby, 5 for the adult, total of 7. Then, I'll add in the extra information, the 42 that we were given. 42 fish in total. Now, I'll just need to know that that is 6 lots of 7. So there must be 6 lots of 5 fed to the adult, 30. There must be 6 lots of 2, 12. And of course that should all add up, which it does. The answer, therefore, of course, is 30, the amount given to the adults. The ratios will be laid out in the same way in the second example as well. The difference this time is that we're given the 45 for the adults. This is 9 lots of 5, so I'll need 9 lots of 2, 18, 9 lots of 7, 63, and to identify the important piece of information, the 18 fish that are fed to the baby. So, as ever, we'll finish with a really difficult question. If you're feeling confident, have a go. Can you work out how many sweets were in the bag to start off with? Now, again, to begin with, I'll write all that information down. Also, I should realise that if the ratio is 4 to 3 to start with, the total number of sweets must be a multiple of 7. I could then attempt the question by trial and error. Say there were 14 sweets. That would be a ratio of 8 to 6. If you then ate 4 of them, it would leave a ratio of 8 to 2. Now, that can't be right, because that cancels down to a ratio of 4 to 1. Now, if you kept experimenting with the different ratios starting with a multiple of 7, eventually you'll get to 28 sweets, 16 yellow and 12 red. Then, if 4 of the red sweets are eaten, that will leave 16 yellow and 8 red, a total of 24. Now, 16 and 8 is of course in the ratio 2 to 1, because for every 2 here, there's 1 there. So, how many sweets must have been in the bag to start off with? 28. I hope you enjoyed and learnt a lot from this video. Make sure that you get this signed from your parents to show that you've done it. Show us your workings. And again, we'll be ready for you in class.